hardest. So in my opinion, 9.2 is the most important section in this chapter. Okay, so it is deriving trig functions. It's not incredibly hard. Okay, the hard part is just remembering which derivative to use. Okay, so the beginning of this shows how they have come up with the derivatives. Okay, so if you go back to thinking about the sine and then the slope of the sine at each of these spots. Okay, so if we're going to take the derivative and graph this derivative down here, okay, we're analyzing the slope of this graph at each point, right? So if we were to start at negative 2 pi, what would you say is about the slope right there? 1. And you're right, it is exactly 1, in fact. Okay, when you get to negative 3 pi over 2, what would you say is the slope right there? So remember the slope, it's a maximum. 0, so at a maximum it's 0. Now, here you go. What is the slope at negative pi? Probably negative 1. Yep, exactly negative 1, in fact. Okay, what about at pi over 2, negative pi over 2? Back to 0. Okay. What about at 0? 1. Uh-huh. What about at pi over 2? What's that? Back to 0. Yeah, isn't this interesting? Okay, and then at pi, now we're at negative 1. Okay, and then, yep, 0. And then 1 again. Okay, so what did I just create? What is the derivative of the sine function? Cosine function. Isn't it nuts? That wasn't a perfect drawing, but you get the idea. So the derivative of the sine function is the cosine function. So let's think about the cosine function. If we were going to analyze, and I'm not going to go as in depth, but let's start right here. Okay, what's the derivative at 0? What's the slope at 0? 0. Okay, so it started at 0. What's the slope here? Negative 1. So it's going 0 to negative 1. Back to 0. So what's the derivative of cosine? Close. Goes down first. Negative sign. Okay. So the derivative of cosine is negative sign. There we go. All right, so there it is. There's the important stuff. So circle that, highlight it, memorize it. Okay, so let's take a kind of a quick look at this and kind of maybe help you memorize it. Okay, so I always think that the very first trig function that you ever think of is sine. So the first one they always talk about is sine. So the derivative of sine is the next one, the cosine. That's easy to remember, right? Okay, and then what is this stuff with the u's? The hook-ons, exactly. Okay, so it's the same idea as when we were in chapter 7 when we had that hook-on, you always multiply by the derivative of the hook-on piece. Okay, so if there happens to be something inside after the sine, you just multiply by the derivative of it. Very simple. Okay, this occurs on all of these functions. Okay, cosine, derivative of cosine is negative sign. Do you notice anything about this side? Ah, okay, so this is how I remember this. If you're deriving a function that starts with a c, it's negative. Okay, derivatives that start with a c are negatives. Okay, if you look at cotangent, what is the derivative of cotangent? Cosecant. Notice that they start with c's. Cosecant squared. That's how I remember that. Cotangent and cosecants are derivatives of each other's. Okay, but what is the derivative of cosecant? Itself times cotangent. This would be a good one, right? Yeah. Unless you memorize it. It's not that hard to memorize. Okay, so if we go back over here, the derivative of tangent is secant squared. So notice that there's a relationship between tangent and cotangents. Okay, they're secant squareds and cosecant squareds. Interesting. Okay, and there's also a relationship between secants and cosecants. They derive into themselves times the tangent or the cotangent. Okay. So it's not like totally random stuff. There's kind of like a connections. There's a pattern going on. Okay, so let's go ahead and do this. Let's start with number 1. What is the derivative of cosine of 3x squared? So first, what's the derivative of cosine? Negative sine. So we'd say, okay, it would be negative sine. I did draw a negative, but it didn't show. There it is. And then what do I have to multiply by? The derivative of 3x squared, which is 6x. Okay, so you probably would want to write that as negative 6x times the sine of 3x squared. Pretty easy. See, it's not hard. Okay, what about number 2? It is a little munkier. Now notice that it has tangent to the 4th degree. Now, the one thing about trig functions with exponents is they're kind of drawn in a way that doesn't really make sense in your brain, I think. Because the way you should be thinking about this is that we have a tangent of 5x that's all to the 4th power. Okay, so anytime you have a quantity with an exponent, you have to use the chain rule. Okay, so remember the chain rule is the derivative of the outside times the derivative of the inside. Okay, so when I go to derive this, the derivative of the outside would become 4, the tangent of 5x, cubed. And then what's the derivative of the inside? What is the derivative of tangents? What? 5. Okay, so we're going to throw the 5. And then, but what's the derivative of tangent? Secant squared. So it'd be secant squared of 5x times 5. Yep, which I put in the front. Okay, so you should probably write this correctly. And since you have a 4 times a 5, that makes 20. And I would write this as the tangent cubed of 5x times secant squared of 5x. I don't know why the math god decided to say it that way, but there you go. Maybe I thought it looked better. Outside? Sure. Sometimes. Usually he makes it easier, but that time, I don't know. It looks cooler, I guess. Alright, how do I do the derivative of cosecant? What is the derivative of cosecant? Negative. Good. Negative cosecant, whoops, cosecant times cotangent. And then what do I have to multiply by? What's the derivative of t over 2? Remember, that's the same as 1/2 t. 1/2. There you go. So times 1/2. So I should probably really write that as negative 1/2 cosecant of t over 2 times the cotangent of t over 2. Okay. What about question number 4? There you go. Okay, so product rule, yeah. You guys were all thinking it, you just all said it in your own way, real different ways. Okay, so there are two x's. We're going to do product. We have our first is going to be the e to the negative 2x piece. Well, I wouldn't use that word, but I probably would say hooray. Okay, so we got first. Hold on, it's not catched up. It's stalled or paused. Okay, so I'm gonna do a first d second plus second d first. So my first. Are we good? Are we good? I know I took a break there. First. Okay, what's my d second? What's the derivative of cotangent? Negative cosecant squared, right? And it's just straight up of x. Okay, then plus second. Are you guys good in the back there?
Oh, yeah.
Okay, second d first. So what's the derivative of e to the negative 2x? You remember that rule? Yeah, you just derive the exponent, negative 2, and then times itself, basically. It all comes back. Those rules that you learned in chapter 7 are going to come into play here. So I would probably write this as negative. What'd you say? This is a good time for me to talk about a different way this could potentially be written. Okay, this would be one way. On a multiple choice, it might be written in factored form. Okay, so how would I factor this? What could I pull out of both terms? Yeah, so I could pull out a negative e to the negative 2x. Whoops, I have an x. What are we doing with t's? I don't know why I have a t. My bad. 2x. Okay, so then you'd have cosecant squared plus 2 cotangents. Okay, so you might see that written one of two ways. Good there? It's all coming together. I know, that's what's so cool about this, right? It's like it all just, oh, now we can do all these things. Alright, example 5. Okay, so example 5 says, without a calculator, find the slope of the graph of y equals blah, 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 where the x value is blah, blah, blah. So, good. Anytime I'm looking for slope, I find the first derivative, and then I can plug in whatever x value they gave to me. Okay, so I'm going to start by finding the derivative of my y. So I have a 3 there, so I'm going to write 3, and then I'm going to derive, or multiply by the derivative of cosine, which is negative sine. So I have times negative sine of negative x, and then I have to multiply by the derivative of negative x, which is... No.
Wait, is that a negative x?
Yes, it is. Sorry, that is not very legible. I haven't got there yet. Why do you keep the 3? You always keep the 3 when you derive. Like if you had 3x squared, that's really the same as 3 times 2x squared, right? We just always multiply and go straight to 6. But if there's a number in front, we just multiply. No, it's not 3 plus. It's 3 times the cosine. So it's multiplied. Okay, did we figure out what the derivative of negative x is yet?
I think it's negative.
I think so. Okay, so then I basically see we have a negative, so I would call this just 3 sines of negative x. Okay, so that's my first derivative. So now I'm going to find the slope at pi over 2. So I'm going to plug in pi over 2. So there's my notation for, sorry, I'm not writing very nicely for that. So I'm going to go to negative pi over 2 on my unit circle. So negative pi over 2 goes straight down. The sign is reference to the y. So what's the y value at negative pi over 2?
1.
Close.
Negative 1.
Negative 1. So basically I have 3 times negative 1, and we get a slope of -3. Okay, so for b, I can steal some of my work and simply just plug in -pi/3. So I'm going to have 3 times the sine of, and since we have a negative, I'm going to go ahead and call that pi/3. Okay, so pi/3 on the unit circle. We're talking about the y, that's going to be the long length. So we're looking at the square root of 3/2. Because, yeah, we have a negative. Good there? Thank you. Okay, number 6. Okay, so number 6, this is very interesting. Are you guys ready? This is a gigantuous idea. I'm going to teach you something that you haven't learned yet. So you know how we skipped a chapter? Okay, so this question is related to something that we skipped. It's called L'Hopital's rule. L'Hopital.
Are they ever going to do that and write this on a test? Be like, oh, use L'Hopital's rule, whatever.
I don't know. I don't think so, but possibly. It's very simple though. Okay, so this is the way it works. Okay, so we know that if I'm going to find a limit, that I would start by plugging 1 in, right? That's how you start it. So if I plugged 1 in, I would have the tangent of 1 minus 1, so the tangent of 0. Okay, so if you think of going to 0 degrees, the ordered pair there is 1, 0, and tangent is the y over the x, so I would end up with 0/1. So it's 0/1. 0, so I'd get 0. If I plug 1 into the denominator, what is the natural log of 1? 0. Okay, now in the past, when you get 0/0, you would go, oh, okay, now I got to factor this because I can reduce it somehow. Well, that's not very factorable.
Do you always plug 1?
Yeah, you start by plugging whatever the limit is in. Yep. Okay. So, if you can't factor this, you can use L'Hopital's rule, which is basically all you're going to do is derive the top, then derive the bottom, and then you can plug in your limit. Yes.
Does this work? Does this rule work just for this, or would it work for
Always. Yes. Yes.
So derive the top.
Yep. So you could have used that instead of factoring. So the method that I showed you that you used instead of factoring, you could have used L'Hopital's rule.
So you can use it with everything? Spell that?
Yes. Yep. Any functions. I can try.
Oh,
I know the first 4 letters are right,
Perfect.
but I'm a math teacher. Don't ask me to spell correctly.
That's right.
Roughly. Is that correct? Oh, yes. I should probably earn extra credit for that. Okay. Anyways, this is what we're going to do. Are you ready? We're going to take the derivative. So, what is the derivative of tangent? Tangent was cosecant squared. So we have, or secant, I said co, sorry. Secant squared of x minus 1, and then I'd have to multiply by the derivative of x minus 1, which is 1. Okay, so I'm not going to write that. And then I have to derive the bottom. So what's the derivative of the natural log of x? Anybody remember? Nice, very good. Okay, so in this case, I have a fraction in the bottom, so I'm going to start by multiplying by the reciprocal. So I have x times the secant squared of x minus 1. Okay, awesome, I just got rid of the fraction. Okay, so now I'm going to take the limit, I'm going to plug 1 in. So I have 1 times the secant squared of 1 minus 1. Okay, so 1 minus 1 is 0. Okay, so I'm thinking about the angle of 0. Okay, ordered pair there is, what was it, 1, 0. So secant is the reciprocal of the x value. So that was 1. What's the reciprocal of 1? 1. So I have 1 times 1, which is, it is 1. Yeah. No, not always. I use the unit circle in my brain. So we're looking at 0. Kinda. Roughly. Well, 1 squared. Yeah. Yeah, so if you got like 1/2, let's just say 1/2, then you would square the 1/2. Yep. Yep. They're right over here. Okay, last question, I think, right? Is this our last one?
Yeah.
All right, let's do this. Last one. Okay, so this one says, find the x values for the relative extrema for our function. How do I find extremes? Derive it, okay? So first derivative, this is going back to what we learned a long time ago in chapter We're just going to derive it. We're going to set it equal to 0. Okay, so what's the derivative of sine? Cosine. And what is the derivative of cosine? Negative sine, so I'm going to say plus sine. Okay, and then to find my extremas, I set that equal to 0 and look for my critical numbers. How do I solve this if I have 0 is equal to cosine plus sine? Maybe. Let's try to do this without a calculator. I think you can do this. Okay, so what I can do is I can set them equal to each other, which is a rare thing that you would ever want to do, but it works in this case. Okay, so the idea is that I want my cosine to equal my sine, but one is going to be negative and one's going to be positive. Okay, so if you're thinking about the unit circle, the cosine is the x and the sine is the y. So where on the unit circle is the x value exactly the same as the y value, except for one is positive and one is negative? 3 pi over what? 3 pi over 4, there's another spot. Down on the third quadrant. 7 pi over 4. Okay, everybody okay with how I figured that out? That helps.
How come 7 pi over 4 when x is positive sine?
Because you can throw the negative to the other side and make it go the other way. Yep. Okay, so these are my critical values. Sorry, my 3 looks like a blotch of yuckiness. There we go. That's a better 3. Okay, so I need to figure out if these are maxes or mins. Okay, so I need a value that is smaller than 3 pi over 4 on the unit circle. 0 is very easy. So if I plug 0 into, let's go to this spot right here, where my blue arrow is. If I plug 0 in there, the cosine of 0 is 1, and the sine of 0 is 0, so that makes a positive number. Okay, what's a number between 3 pi over 4 and 7 pi over 4? That would be really easy.
4 pi over 4.
So pi? Good one. Okay, I had to think about that. Good. Okay, pi. So pi, the ordered pair there is -1 and 0. So if I have the cosine, that's the x. So -1 plus 0, that's a negative number. Okay, and then a number that's bigger than 7 pi over 4. 2 pi. I like that one. Okay. That one's going to be the same as 0, right? So I can go straight to, that's a plus. Okay, so I go up, then I go down, then I go up. So what is 3 pi over 4? A max. So this is going to be a relative max at x equals 3 pi over 4. And do notice that the question asks for x values only. Okay, on the assignment, I think they asked for points. Okay, so how would you find the corresponding y value for that? Plug it back into the original. Good. So that makes 7 pi over 4 a relative minimum. Oops, 7 pi over 4. Awesome.
So what you do to positive, negative again?
Oh, I just used, start at 3 pi, so a number that is less than 3 pi over 4 would be 0. So thinking on the unit circle, 0. So the point there is 1, 0. So I plugged it back into that equation, that I have my blue arrow next to.
So it's
0. So the angle of 0.
So 1 plus 0.
So 1 plus 0, yep.
I see.
so it's not necessarily okay, cosine of pi.
Right. Right. So I'm thinking unit circle.
So it really would be memorize that.
I think so. I mean, it's not like it's incredibly hard. If you can memorize the first quadrant and those angles, they just get nearer. Yeah. Yeah. All right. So you must do. Let's see. For your assignment, you have to do 1 through 21 for your problems. Okay. This particular assignment goes all the way to like 37 or something like that. 39. So, even though that's a lot of problems, as I said at the very beginning of this is the most important section in this chapter. If there was ever an assignment for you to do more problems on, this would be the assignment I would suggest to you. It would be the most valuable to you. Okay?